Oh yeah, in this video we're going to talk about how to rationalize the denominator. What is that? Basically, when you have a square root in the denominator, after all simplifying is said and done in terms of simplifying the fractions, then we go to work and we change the denominator into a rational number. Remember, a square root like the square root of 5 that is not a perfect square is considered irrational. We want to make it rational, so we call it rationalizing. So I'll write that up here so you see that word, rationalize. Sometimes that's the instructions. The denominator, and I'll just call it the denom. All right, so that's oftentimes the instructions. So what do? Well, first, as I've shown you in a previous video, you look to see if you can simplify everything under square roots. Well, 4 is not underneath the square root, only 5 is, so there's nothing that can be simplified in terms of the fractions. So that leaves us looking at, can we simplify the square root? 5 has no perfect squares in it, so it's in simplest radical form. So oftentimes we need to get rid of the square root in the denominator. That's not considered simplified if you have a radical in the basement, or if you have a square root in the denominator. Now, in much later math, calculus and beyond, a lot of teachers leave that to the wayside. Like with improper fractions, they end up being okay, so do square roots in the denominator. But for many years, maybe all your math lives, you might need to get rid of the square root. Let's do it. So to get rid of the square root, what I do, and what you should do, is you should think, what would make this square root go away? Well, if I multiplied by the square root of 5, that would give me a perfect square. So you multiply by the square root of 5, and we do that because root 5 times root 5 is 5, right? Because you get the square root of 25, which is 5, or the square root of 5 squared. In an earlier video, I show you why multiplying the square root by itself leaves you with whatever is inside the radical. So the square root of 5 times the square root of 5 will give us 5. Now, whatever I did to the denominator, I must do to the numerator. Otherwise, if we only multiply the denominator by the square root of 5, you have changed the value of this fraction. By multiplying top and bottom by the same number, we're multiplying by 1. So we have not changed the overall value of the original exercise, the original fraction. Okay, so root 5 times root 5 is 5. That is the rationalization part. We have rationalized the denominator. Sweet. Then what we have left in the numerator is to multiply 4 times the square root of 5, which cannot be simplified any further, and we're done. That's it. Now a common error happens here where students will say, oh, and 5 divided by 5 is 1. No, this 5 is underneath the square root. So in terms of order of operations, you would have to do the square root first, it's a grouping symbol, and then divide by 5. That is why we cannot divide 5 by 5. That square root is an operation. So you don't get 1. The square root of 5 is approximately 2.2-ish and change. All right, on to 10 times the square, or 10 over, I should say, 10 divided by the square root of 8. Now, again, we do not look to simplify 10 and 8. Even though 2 goes into 8 and 10, the square root is an operation that groups the 8 and would need to be done first before any division happens between 10 and 8. And so 10 cannot divide with 8 because the square root of 8 is somewhere around 2 and change. 2.7, 2.8, somewhere around there. So they will not divide out. However, we can simplify the square root of 8 quite a bit. So I'm going to simplify that down and rewrite this as 10 over the square root of 8 is the square root of 4 times the square root of 2. So if you can reduce the square root, do that. So that is going to be 2 root 2. Okay, that makes life a lot easier. A couple of things here. First of all, 10 can divide by 2. 2 is not underneath a radical, it's not grouped. 10 divided by 2 is 5. So you have 5 over the square root of 2. Now notice we still have a radical in the basement, a square root. So, like we did in the last problem, now that everything's in simplest form, we need to get rid of the square root. I'm going to multiply by that same square root, root 2. And I'll do that in the numerator and denominator to keep everything equal. The square root of 2 times itself, the square root of 2 is 2. And you're left with 5 times the square root of 2. Sweet. Nothing else left to simplify. Again, remember it's not 2 divided by 2. That square root of 2 is acting on the 2 first. And then you would divide by 2. And by then, the square root of 2 is a decimal, 1.4. So we don't divide it down. All right, here we go. Now we've got a fraction, 14 over 21. They're both underneath the radical, so what I would do is, as always, if you have a fraction and they're both under the radical, simplify what's under the radical first. It makes life a lot easier and the number's much smaller. So 14 over 21, we can divide numerator and denominator by 7, and that leaves me with the radical of 2 over 3, the square root of 2/3. Now from here, I've got to separate this into two separate radicals, the square root of 2 over the square root of 3. Now having the square root in the numerator is fine. In convention, what we typically say is that this is not in simplest radical form because there's a square root in the denominator. We'll get rid of it again by multiplying by that same square root to make it a perfect square. So we get the square root of 3, square root of 3. Root 3 times root 3 is 3. That's nice. So we got that all over 3. Root 2 times root 3, well, let's check it out. 2 and 3 are both in simplest radical form. They don't share any common factors, so when we multiply them, we'll get a number also in simplest radical form. And another reminder, I'll say it one more time, do not do 6 divided by 3 to get root 2. The square root acts on the 6. Gets you a weird decimal that doesn't divide by 3. So this is in simplest radical form. We're done. We have no more denominator with the square root. That's it. It's all about getting the radical out of the basement or rationalizing the denominator. A cool skill you're going to use a lot.